This is problem 4 from the mock test. Red Elk is circling planet something, right? Planet Zircon. It's a different name on the test. At a speed of 4230. So here's again, it's an orbit one, right? And here's Red Elk in his spaceship. Let's make him go that way, right? And here's the planet Zircon. And he's going 4,230 meters per second. His spaceship has a mass of 11,250 kilograms. Right? This distance here is from the center to the center. It's the distance you want to use is 8.82 times 10 to the 6th meters. Right? And it says, what is his period of orbit in hours? Holy cow. How are we going to do this? Well, the thing to do, I think, is just use this notion, right? That velocity is just the circumference divided by the period, right? And so therefore, we can just plug in numbers. 4,230 meters per second equals 2 pi times 8.82 E6, right? Divided by the period, right? So the period is going to be this divided by that. It will be the period, right? So 2 pi 8.82 E6 divided by 4230. And that is 13,101.1 seconds. And then divide by 3,600 to get hours. And we get 3.64 hours. And this is just unusual. I just asked for hours, and that's because on the test, I give you hours, and I want you to calculate seconds, right? So here, we got seconds, and I make you calculate hours, because it can't be exactly like the test, right? Okay? So, but normally, if you got seconds, that'd be great. That'd be your answer. You could circle that on the test. That's fine. But I'm going to give you hours on the test, and you're going to need to multiply by 3,600 to get seconds, because seconds are what you really want to use. Okay? So that's the first one. The second one says, what's the centripetal acceleration of his ship? For B, I'm going to choose the easiest thing. I'm going to use A as V squared over R. Right? So it's 4230 meters per second. That's squared divided by 8.82. E6 meters. So 4230 squared divided by 8.82 E6. And this is 2.028. Okay, good enough. 2.02867. And then what is the mass of planet Zircon? Lots of ways we could do this one, but I think I'm going to use orbit to solve this one, C, right? So I'm going to use G, mass of Zircon, mass of Red Elk's spaceship, right? Okay, over R squared is the mass of the spaceship, V squared over R. Because we have the velocity, we got the radius, right? The spaceship or the satellite mass cancels, and we want the mass of the planet, right? So I'm going to go, oh, we can cancel an R too, can't we? Like that. So I'm going to go V squared R divided by G. So I just put the G down there and the R up there. Get that, right? And then literally in my calculator, I'm going to type in, I don't need a parenthesis, I'm just going to go 4230. No Fridaying, squared times 8.82 E6 divided by 6.67 E minus 11. So 4230 squared divided by 8.82 E 6. When I divided, I needed to multiply. So times 4230 squared times 8.82. Now we got to divide. Divided by 6.67 e minus 11. Wow. E squared. Oh, that's the mass. I'm like, I thought this was something else. Okay, 2.366 times 10 to the 24th kilograms is what I get. Is that what I got? That is what I got. Here we are. You could, if you wanted to, you could have also solved C this way. You could have also said that the force is MA, right? And used the ship's mass, right? And gone this times, so 2.02867 equals, or times 11,250 would equal the force, and then you could just say that force equals G times mm over r squared. But you're basically doing the same thing we did here. It's not really a workaround. So that's probably confusing. I'll just erase that. More than one way to do it. Are there questions about number 4? Are we good? It was good? All right.